Bittersweet job with WAPTEK, the troll life feed. NASA hoax, fisheye GoPro, space rocket launch, you shall not pass God's sky firmament dome. Jesus, it's cold out here. Otherwise known as the yo-yo dyne rule. Some of you know where that comes from. A yo-yo de-spin mechanism. Yes, somebody named it that. Device is used to reduce or stop the spin of a rocket when it's fired up, as long as it's using solid fuel, because if it was spinning to stabilize itself, the same reason you spin a bullet, it would slosh liquid fuel around. So these are solid fuel rockets being launched up. And you'll see a video, and I've got a link below that explains it, where somebody took one of these videos of a rocket being launched and cut it off right at the point where it wouldn't agree with their worldview, or at least what they were trolling at. And it showed it hitting the sky dome because God stopped him. The hand of God stopped him. By the way, if anybody's curious, the hand of God is a joke within video game engines. If anybody wants me to explain that, I'll tell you later, but it's literally a game joke. You might want to think about that for a second. What is this yo-yo de-spin mechanism? It consists of two lengths of cable with weights on the ends. These cables are usually wrapped around the final stage and or payload in a manner of a double yo-yo. So as it spins, it keeps it wound tight. At some point, the weights are released, forcefully sometimes, and sometimes they're in the wrong direction so that it will fly off in all directions. And this has the effect of spinning it down by transferring angular momentum to the weights, and it's based on the distance out from the center. Just like you pull your arms in when you're sitting in that office chair at work where you're spinning, you'll spin faster, and when you put your arms out, you slow down. You can even time it to where you come to a dead stop, or almost. And it can be reducing the spin almost to zero, or at least a manageable level where some other thing like a gyroscope can spin up temporarily to restabilize it. In order to make these missiles go up straight, and they are going straight up in most cases, they're not trying to go into an orbit of any kind, they have to be spin stabilized. So they spin stabilize them for the same reason you have rifling in a rifle. That's why we call it a rifle. The relatively small weights can also be used as long as they have long cables. The further out it goes, the better. It's the square of the length of the cable, so every time you double the length of the cable, you'll quadruple the effect you can have on the same weight, because it's based on the squared laws. But anyway, the Dawn mission, for instance, had 3 kilograms of weights and 12-meter long cables to do it, and it ended up spinning it backwards from 36 RPM to 3, and that thing weighed 1,420 kilograms. These can also end up being used as keeping it spinning and using them as very useful antennas in some cases. Weights are often released along with the cable, and typically right after the launch is finished, where there's no atmosphere, so there's no need to spin stabilize it anymore. As long as they're not going to make any maneuvers, they do this, and then they can use thrusters. Sometimes they use thrusters. If it's a liquid fuel rocket, they use thrusters instead. And the fins on the back keep it straight up enough, and they will not spin stabilize it. They'll just use some other method. It's cheap, simple, quick and dirty, and releasing weights that come out to a point and stop and kind of drag it backwards from spinning, it's really easy to do. You can even just do it with having the cables wrapped around, and that's it. That's why on the one that shows it hitting the dome of the firmament, you see a bunch of shredded material below. That's where the cables were hidden. They were hidden underneath a layer of basically fiber tape, and the cables came out and shredded it. And then at a certain point they dislodge, or whatever. Looking at a rear view cam of the thing, it's the same one, you can see the exhaust rail, and it's a straight line, so that shows that it's probably not going in a curve of any kind. So it's not accelerating for or against the rotation of the Earth trying to go into escape velocity so that it can achieve low Earth orbit or anything. It's just going to go up and come back down. These are for height and altitude tests or even world record attempts. Just falls back at whatever terminal velocity it runs into with the air level at that altitude. The thinner the air, the faster it can fall without actually going to terminal velocity. If it could go into orbit, it has to go to a very, very high speed, downrange as well, which means the pattern, if it was rotating like that, which may not even happen, because it'd be hard to turn it, if you were able to see one of those, it would show the pathway bending and curving, which is what you see with the space shuttle and most other launches. They don't go up and then stop and land in the ocean, killing off astronaut after astronaut. They're going against, or usually for, the rotation of the Earth to achieve, 5,000, 10,000 miles an hour speed. As soon as they get up in a higher enough atmosphere, they have less air to push against. And yes, once they get high enough to be able to do this extremely high speed, re-entering at that speed would cause them to cause a heat shield to be needed, and it might burn up. These things, however, these little rockets just go up and come back down. They're not moving fast enough to burn up unless they manage to escape the atmosphere, which is pretty hard. It has to go up 50 miles or more, and then keep going as hardcore as possible until they come out very, very high. And at that point, they're using more energy than they need to do an altitude. It would be better for them to achieve a nearly escape velocity or an orbit and just change the orbit. It's a lot easier to change orbital altitudes when you're already orbiting. And again, in the vacuum of space, this works well. And on that point, why do you hear high-pitched whine about it in space, or seemingly in space? Well, the atmosphere at that altitude is very thin, but it's not quite a complete vacuum. And you'll hear higher notes from everything simply because it's thinner air, for the same reason helium makes you talk like a munchkin. Next, yes, there are thousands of those objects up in space orbiting the Earth, and they average in size, let's say, like a car. But since it's 200 miles up or something, do you really believe you're going to see a car at 200 miles and be able to identify it? You might see a glint of light, and you can get a telescope and or binoculars and see them. Some of them are very, very visible. But this assumption, I can't see them there, therefore they're not there. Okay, I want you to find a place that's high enough for you to see even 20 or 30 miles away and see if you can see with your naked eye an actual car. And yes, someone else gets to move them around and say, okay, what color is it? You can't really do that. Normally can't. Where's the sound coming from if it's in space? Well, the rocket's body is conducting sound. When they separate in pieces, you don't hear the other part doing anything. You don't hear any sound from it. It's conducting sound through metal. This is the same technique you use with a metal rod pressed against your engine, and you put it up next to your ear to hear the engine, so you don't have to hear. You can isolate the sound of that part of the engine from the exhaust system or people yelling in the building. Everybody who's been a mechanic knows about that. Well, this is the same thing that causes the sound conduction through the framework of a missile, or in this case, a experimental rocket. What about the extreme temperatures in space? Well, they do have extremes. Someone quoted 2,000 degrees Celsius or 20,000. People throw numbers around. You're sure that's Celsius instead of Kelvin, right? I know for a fact people were quoting Kelvin, but here we go. Let's go with this. Heat gets dissipated from a spacecraft if it's in vacuum by passive radiation, infrared radiation going out. Infrared radiation doesn't really remove a lot of heat, but it can. It takes a long time for it to reach the equilibrium of the actual temperature in space. However, being hit with sunlight when there's no atmosphere, just like on a sunny day, will heat up almost anything. So you have to understand it's going to get warm on one side. On the other side, it'll still be whatever low temperature it is until the heat conducts through, sort of like sound conducting. In space, since there's nothing for the heat to go into, space is effectively considered cold, but not quite. This isn't a simple answer. It's almost like a trick question, but let's cover this real quick. The cosmic background temperature, which is at minus 455 degrees Fahrenheit, because you've got to convert it to Fahrenheit, people won't understand Kelvin. Some parts of space are very hot, thousands or even millions of degrees. I'm not saying which one. Is it Kelvin? Is it Celsius? Or is it Fahrenheit? Well, this is when it's visible or an infrared gas between stars. That's where people are missing that quote. Oh yeah, you mean the corona of a sun might be hot? Yeah, I think it might be. Okay, so anyway, next. What about the solar wind? It's hot. Again, are you doing Kelvin again? Is it really hot? Does anybody want to answer that question without lying? Some people are cooking this evidence, including cutting off that video I'm talking about with a missile being launched, just right so you don't have to see it wobble out of position and tumble, so you can see a black sky during bright daylight and the moon, because that gets in the way of saying that it hit the dome of the Earth when it would be at that point above it, because the black sky would indicate it's outside of the dome of the Earth, which means there isn't any dome of the Earth. So let's try the rest of it. What about what about a metal plate in low Earth orbit? What is the temperature range it deals with? Well, negative 170 to positive 120 Celsius. Any region close to the Earth would have that kind of range just based on how much sunlight hits it and how long and whether it reaches equilibrium, from negative 274 to positive 253 Fahrenheit now. Got to mix and match. And from Space Shuttle in black space, it reads negative 269 centigrade, which is only 1 degree above the negative temperature of 270. Well, what about Kelvin? Let's talk about Kelvin. Actually, after all, we're doing Fahrenheit chess with a Kelvin pigeon who keeps refusing to admit this. Okay, so what's body temperature? That's 310 approximately degrees Kelvin. What about negative 396 degrees Fahrenheit? That's 35 Kelvin. 35 Kelvin is based on making a temperature measurement that's based on some absolute zero number, or at least try to. But the problem is there isn't any temperature in space, essentially. Temperatures are measured of the vibration or velocity of a collection of atoms or molecules. Since a vacuum doesn't contain that, that's an irrational reference. That's like asking how much money you have in your left ear instead of inside of your pocket. You're asking the wrong question for the wrong answer. And people who do this know this. If you're in a vacuum of space, you really don't have much of anything to measure temperature from. But if you wanted to measure it, depending on if it's exposed to sunlight, it would have a certain temperature to it. But it would take a long time for it to achieve that temperature, or equalize, except when the sun hits it. It heats up very rapidly from the sun and cools down over a long period of time. This is also the reason that a vacuum can also be used as insulation to keep heat from escaping, because there's no conductivity. So, what about that? Since there's no molecules, we don't really have any heat transfer point of view, so we don't really have a measurement. But, again, a piece of metal out in, like, let's say the space shuttle, is going to achieve a certain temperature. And it'll stay that way a lot longer. What about the Earth's location in our galaxy? Why is it changing all the time? The Mandela effect. Nice try, NASA. That's somebody in that comment. Oh, you mean all those pictures of the Andromeda galaxy where someone pointed an arrow and said, "You are here"? That's an astronomy in-joke about how you don't know the difference between the very famous Andromeda galaxy and our galaxy that hasn't been photographed because we haven't got a satellite or anything out that far to photograph our galaxy. We have models of what it's shaped like, and that's good, but that's like saying, well, why don't you have a photo from space of North America long before the Wright brothers took off? Because we don't. We just have maps, and they were pretty damn accurate. Currently, the mapping of our galaxy has one image, and we're in a specific part of it. But let's read Douglas Adams. Far out in an uncharted backwater of an unfashionable end of the western spiral arm of the galaxy lies the small, unregarded yellow sun. We didn't have the Kepler and Hubble back then, or other high-definition equipment spinning around the globe, snapping pictures, and getting into the depths of it all. But yeah, if you're going to look at a picture of the Andromeda galaxy with an arrow pointed at it, I'd say that's not a Mandela moment. I would say that's not our galaxy. The estimates of our location in a galaxy are updated as much as they can be, but they can be completely wrong depending on who you're talking to. And the other images that are not the Andromeda galaxy, which almost none of them are artist renditions and paintings. So why are you pointing to that being a Mandela effect when it's just some artist's interpretation? I'd like to point out a lot of people who do these sorts of insulting comments to me also say that, oh, well, NASA fakes everything. Okay. One of the videos trying to prove that there's a dome of the firmament cuts off, so it's not technically lying, but it cuts off the part that gets inconveniently in the way because it contains facts. Other people point at paintings and stuff and say, see, it proves where we are in the galaxy and it's changed. But if you show an artist's rendition of the Earth, a painting, they say, well, that's just a painting. It's not a real picture. We have not just a little bit of a double standard here. We have outright lying. Now, who wants to make everyone in the United States look like a moron? Who wants to make us look like the least technologically advanced part of the planet? Who wants to make us look like a bunch of reactionary idiots that deserve to be bombed? Every opponent we've ever had. Has it gotten through any of your heads? Now, every one of you that keeps repeating this stuff verbatim and obeying rule number 1 of being part of a cult, don't question the cult leader, and don't listen to opposing views. How many of you are realizing you're working for the opponents? Does it hurt? I don't like getting fooled either. I don't like getting lied to either. Can you get a little angry at the people who are lying to you instead of the people who are telling you the truth? NASA isn't lying to you. I'm not either. You're being lied to and you're repeating it. It takes 2 to lie. 1 to lie and 1 to repeat it. Thanks for watching. Have a good day. Good luck with that. And if there isn't any dome of the firmament, knock it off.